Well, good morning again. This module, we're going to be talking mostly about contrast as it relates to safety. But before we get into the contrast that we inject, I want to talk just a little bit about image contrast because it's very easy to get confused when we start hearing the word contrast back and forth. First of all, there are two things that can affect image contrast. Things that are found already in the body that you have absolutely no control over, and things that you do have a control over called extrinsic contrast parameters. Intrinsic contrast parameters are things that cannot be controlled by you. They are built into the physics of MRI. These are T1 recovery time, T2 decay time, proton density of the tissue, the ADC of the tissue or apparent diffusion coefficient. These are all things that cannot be manipulated. They are inherent. You work around them, but you cannot manipulate them. And then the extrinsic contrast parameters. These are things that you as a technologist control right there at the scanner. These are your TR, your TE, your flip angle, your echo train length, your B value. All of these parameters right now sounds like an alphabet soup, but you'll learn what each one of these are. These are parameters you set each and every time you start a pulse sequence. And depending on what type of pulse sequence or what you want the image to look like, what type of contrast, image contrast you want on those pictures, these parameters have to be set in such a way to bring that out. So what are you trying to bring out? You're trying to bring out inherent and image contrast. This is the differences between the high signal tissues and the dark signal tissues or low signal tissues. This is the black and white shadings of the image. That image contrast is determined on how much signal you can get from the tissues. The first type of mechanism that we're going to talk about is relaxation, specifically T1 relaxation. You're going to hear this term used interchangeably with T1 recovery, T1 transit time. For now, we're going to stick with the term T1 relaxation. And what this refers to is the time it takes for a signal to grow back to 63% of its original value. And T2 decay time refers to the time it takes for a signal to decay from to decay to 37% of its original value. The two mechanisms happen at the same time simultaneously, and two tissues of extreme contrast within the body are fat and water. The reason for the extreme differences between fat and water is their molecular size. Fat is this huge molecule, while water is this really tiny, very compact molecule. Another mechanism for inherent image contrast is proton density. Proton density refers to the amount of protons that are packed within a certain volume of tissue. It depends on the tissue. Some tissues have a lot of protons packed in it, some of them don't. That's where the term proton density comes from.